Hello, I'm Jonathan DeJesus, and this is my video report for Project 1. So, for our first assignment, which is 2.5, we were told to build a simple calculator that would prompt the user to enter both a subtotal and a gratuity amount in percentage. And using these values, it would calculate the gratuity here, which is subtotal times gratuity, and also the overall amount, which would use this value here, and also add that to the overall subtotal. And for my output, you can see that here. I use the values that were given online on Canvas, which is 10 for the subtotal and 15% for the gratuity. And here you can see use the correct value, which is gratuity of 1.5 and also overall total of 11.5. So for our second problem, we were told to build a program that would take an input from the user, which would take an integer that ranged from 0 to 1,000. And this program aimed to pretty much add every individual digit in uh, that value. So to do this, I prompted the user to enter an input, which would then be stored in the value in the variable num. And after this, I created another variable called ones, where we would store the ones value of that given uh, value entered from the user. And in order to do this, I took the number and used the modulus operator by 10. And what this did was pretty much divide num by 10, and it would take the remainder of this value. So if the number was 932, it would divide it by 10 until it would give a remainder, which would be 2. So this pretty much extracts the final digit of a value. And after that, we would divide that number by 10. And what this would do was it would pretty much remove the final digit since since these are integers. So if you divide it by 10, it would not have any decimals. So for the hundreds place, we would then pretty much repeat this process done for the ones place. We would use the modulus operator by 10, which would pretty much isolate the final variable or the final digit, and we would sort it in the hundreds variable. We would then use num divided by 10 to pretty much remove the final digit. And we didn't have to repeat this process for the final digit, which would be the thousands place, because it would be isolated by itself already. So here we pretty much just output to the user this right here, which pretty much just adds all individual digits. And yeah. So for my output, I use the same numbers used in Canvas, which is 932. And if you take 9 plus 3 plus 2, you get 14. So my program outputs the correct value. So for our third problem in this project, we were told to build a simple financial application that would pretty much ask the user for an amount that they would store in a savings account on a monthly basis, and it would calculate the interest accrued after 6 months. So to do this, I set the initial account number or amount to be 0, and then I prompted the user to enter an amount that they would store on a monthly basis and stored it in here in the amount variable. And in order to do this interest calculation, I use a for loop, and this for loop for every iteration would calculate the interest amount accrued and add it to the account. So here you can see the formula used to calculate this amount, and it pretty much uses account, which would initially be 0, and it would add the amount stored on a monthly basis, which would be whatever the user entered. And then it would multiply that times 1, and then 1.00417, and this 0.00417 is 5 divided by 12, which would give you the interest accrued for every month. And here we pretty much just output this value to the user, which would give the user how much interest this savings account accrued after 6 months. And here in my output, I also use the same number used on Canvas, which was 100. And after 6 months, this is how much interest it should have accrued. So for the last problem, we were told to pretty much calculate the two roots of a quadratic equation. And in order to do this, I prompted the user to enter values for A, B, and C. And these values would be used to calculate the discriminant right here. And this is pretty much like the most important part of this program, as like this value pretty much determines where this program would flow to. If the discriminant is a positive number, it would go here. If it is a negative number, it would go here. And if or it would go here. And if it's if it equals 0, it would go here. So if the discriminant is greater than 0, there would be two roots that would be calculated by these formulas right here, and here's where we would output them to the user. And if the discriminant is less than 0, the program would go here, and this would mean that there are no real roots, and it would output this message to the user. And if the discriminant is 0, that means there's only one root, and we would use the same equation used here, except we wouldn't use the square root d. And here's where we would output that to the user. And here's my output. For A, I use 1. For B, I use -4. And for C, I use 3. And then my program found that root 1 was 3 and root 2 was 1. And pretty much to check this, I used a Symbolab quadratic equation calculator. And here you can see the same numbers. It's 1 for x squared, which would be A, -4 for B, -4x, which would be B, and also 3, which would be C. And here you can see we get the correct roots, which is root 1 is 3 and root 2 is equal to 1, which is the same output that I got in my own program.